Hey. Welcome back to Waterfed Wednesday. If you haven't noticed, we're a little out of practice, it seems. Hopefully, we are up and running. Let's see. Everybody's looks like our moderator's letting us know Instagram is good, so we're up there. Looks like we're back up on Facebook on our business page, our group page, YouTube. We're all good.
Very good. A little late. Better late than never, I guess.
Thanks for bearing with
A
us.
little rusty.
Yeah, absolutely.
Couple weeks off.
That'll do it. That'll do it. So, Waterfed Wednesday. This is episode 5. If this is the first time joining us, Waterfed Wednesday. What's it all about? Well, this is where we go beyond. We like to say go beyond the bucket and dive into the world of waterfed cleaning. Answer your questions about our equipment, our business, and our goal of helping cleaners worldwide get the job done faster, safer, and better. So I'm Alex Brunner, and this is
Sean Gavin.
And we're your hosts of Waterfed Wednesday. So, Sean, are you pumped up?
I'm pumped.
It's
off to a crazy start.
That's right.
I'll be in the 70s the rest of the week, so that's good.
Yeah, absolutely. I know I'm pumped up. We just finished an amazing quarter one. We're pumped up about our second quarter. And for many of you watching, this is when you really get slammed with calls, your schedule's filling up, and boosting your revenue to new heights. So, please excuse my cheesy puns if you haven't caught on. Our segue of being pumped up and talking about boost. Yeah, today's topic is let's get pumped. So our discussion is going to be focused on this week's episode of water pumps. So let's dive in it. We're a little late. So, Sean, fill us in. Why would we need a pump?
Sure. So pumps come into play a lot of times. I mean, the biggest reason for a pump is for increased pressure, so you can get more flow out of your water system, and therefore your pole and your brush. A lot of scenarios will have low pressure, and you'll have to find a way to increase that as the systems without pumps are dependent on one location to the next. So you might run into a property that's on low pressure on a well, that kind of thing, right? So you really want to know your demographic and understand what you're going to run into, because most systems will need a pump in a well application, for instance.
Cool. With that being said, when you go into the world of pumps, there's different options out there. This is a common question we get. So what's the difference between a 12-volt booster pump, a 110-volt booster pump, and a 12-volt delivery pump?
Okay, so a delivery pump essentially has a pressure switch built in. We've got a delivery pump here. Delivery pumps tend to be smaller in their spilling water on me, but delivery pumps tend to be smaller in their capacity. So this is a 1.4 gallon per minute delivery pump. And another thing to understand about these ratings on the pumps themselves. So it'll say open flow 1.4 gallon per minute, and then it will say 90 psi switch. So the pressure switch is on the head of the pump, and what it does is basically turns the pump on and off based on sensing back pressure in the water line. Mm-hmm. So you're siphoning a water tank specifically with this pump. Usually we use these on our fill and goes for all the operators for their reels and their poles. And so essentially you're siphoning a tank with this and you're delivering it to the brush. When you close off the water supply at the brush with your valve, back pressure begins to build, comes back to the pressure switch. Once it reaches 90 psi, this pressure switch turns the motor off. So now the pump's just sitting off, waiting. You open the valve again, the pressure drops from 90 down, and then the water begins to flow as it turns itself back on. So a couple things about the information on the labels generally, right? So this is a 1.4 gallon per minute open flow. So what does open flow mean? Open flow means if you put a siphon line on the inlet to the pump, dropped it in a tank, and had absolutely nothing on the output side, it would push upwards of 1.4 gallons a minute out of this pump. As soon as you put a barb on it, you restrict it slightly, it's dropping incrementally. Every foot of hose, it loses its ability to get there. So open flow is basically nothing on the output, no pressure, back pressure on it. So if you get to 150-foot reel, this is going to put out quite a bit less than 1.4 gallons per minute. Still very adequate for a single operator or single user, but essentially a delivery pump is different from a boost or bypass pump in that it has a pressure switch on the head. So pressure switch mounted to the head here on a delivery pump. Here's a boost pump, and you can see it's much bigger generally, right? So a lot different size. This is a 5.3 gallon per minute bypass or boost pump. And on the face of the pump itself, it has this heat sink. So these pumps tend to get very hot, these booster or bypass pumps. So the heat sink helps protect the motor, give it a little more life, and dissipates the heat off of it through these fins that are built into these heat sinks. So that's what these are on our booster or bypass pumps, as you might call them. So you can see it has no pressure switch. There's no pressure switch built in. So on the output of this pump, what will happen is it will continue to want to build pressure. So internally in the motor head, it bypasses and water stays inside this head, but not a lot. I mean, it's not a big space. So in RO systems, essentially you always have the bypass water.
Right.
So this pump never really shuts off in an RO scenario, and it never really builds up a lot of demand and back pressure on it because it always has the bypass line where water can go out. And so if you look at the specs on this pump, it's a 5.3 gallon per minute pump, and it says switch NA, whereas the other pump said switch 90 PSI. So it tells you the rating. This is a bypass pump. It bypasses at 90 PSI as well. So it won't really build much pressure beyond 90 PSI. It will essentially go into bypass at that point. And another thing to understand about why we don't use pressure switches on these pumps is, as I said, when the delivery pump's pressure switch senses that back pressure, it shuts the pump off. Well, because you always have bypass water or reject water coming out of your RO system, your pressure switch would always be sensing 90 PSI and then a drop, 90 PSI and then a drop. So the pressure switch would be on, off, on, off, on, off, on, off with a application like on an RO system. So you don't want that because the pressure switch would essentially burn out on the pump itself. So that's the two different battery or 12-volt versions of pumps. And then we get into electric pumps. This is the complete electric booster pump system that we sell quite a bit of. It's essentially an electric motor mounted to what they call a rotary vane pump. So the way these rotary vane pumps work is water comes in through one port, it goes around through the pump and out the other port, and this shaft right here mates to the axle, if you will, of the motor, and the motor spins, and it essentially spins the inside of that and creates that force and that suction through and back out. So this is a rotary vane pump. It has a couple of adjustability features built in. There's a bypass screw built right into this acorn-shaped nut. Right out of the box, we generally back this off a little bit because they're kind of tightened down for our application. And then when you get into an actual complete booster pump system, we actually have another regulator on the system that allows you to turn down or up depending on the application. The electric booster pump system will essentially turn any of our systems into a multiple operator system. So if you have a standard rival card, for instance, it's designed to run one pole, one operator. But if you put this electric booster pump before that, now it would run 2 or 3 operators depending on the situation. So that's basically a breakdown of the different kinds of pumps that we use in a various systems.
Cool. I know I gave you an outline, and now that you talked about this, I just want to go off a little bit here. Can you explain the difference of this booster pump that we were talking about and say the transfer pumps that sometimes a lot of guys will use?
Yeah. So, basically what we do, everything we build is for, continuous duty, professional usage. This booster pump's, north of $1,000 as it sits, right? So it's not inexpensive, but it's purpose built. And every time we figure out the next issue with the pump system, we build it in, right? So it's got the regulator, it's got an inline stainless steel screen mesh filter basically on the inline, because a lot of times you might hook up a garden hose and not realize there's a bunch of stuff in it, and it'll come through and then essentially chew up these insides.
Right.
And now this pump head that I was holding before has to be replaced for, a couple few $100s. If you build in the screen, it essentially will protect it. You just have to empty out this filter from time to time. The difference between this and say some of the siphoning pumps that we've seen, most of those are for the irrigation industry.
Right.
They work great in a pinch. You probably get a season out of one. Some people get multiples, but it's somewhat rare. What I found when I was using them was they're made out of cast steel, and it rusts very easily. So essentially, instead of having this brass pump head with the internals being made for continuous duty, what they have is they have a cast iron body that the water is interacting with, and a rubber impeller, right? So
Right.
a lot less, kind of purpose built. And the rubber tends to degrade. That ends up in your filters. The rust, every time you kick it on, you want to make sure it's not hooked up to your system, because it's building up rust in the water that's sitting there. And so you kick that on and now there's rust. So they work in a pinch. Nothing certainly wrong with utilizing one. They'll definitely work for a while and do what you need. But if you're out on a commercial job or a big property and you need one of these things to run, for 4 to 8 hours, I definitely wouldn't be trusting something like that. But it's something to throw in the truck if you run into a well on a typical property or something like that.
Exactly. Just want to check over. We have a comment over on Instagram. This is a good comment. It's from Dave, I think Ruckus. What things should we look out for when buying a used Tucker items? Currently found a fill and go system, 4 years old, on Facebook. So this is actually something we addressed on the last episode, I believe, getting your systems ready. So I know you're watching this on Instagram. So once this stream goes, we're done with it. It doesn't save. So you can head over to our YouTube channel. And you can find episode 5. We'll go into it in detail, but mainly just to help you out. You want to figure out from the owner when's the last time they changed their filters, the RO performance, is it really eliminating the TDS that it should. So please check out episode 4, and you'll get your answers there. But thanks for chiming in. Let me see if I have any other comments before we get back to our questions. Got a good friend, Damien, checking in again.
Yes, hey, Damien.
I think you were out in my neck of the woods. I think I saw you going over to Great Wolf Lodge. Hopefully you and your family had a good time. All right, let's get back into our questions. Let's see. We talked about, okay, here's a good one. How do I decide what is my best option between what we have discussed?
Yeah, so obviously the delivery pumps are made to supply the pole. But if you're looking for a pump that is going to boost the production on the RO side, I would always look to go electric if you can supply it the power, because it's going to be a much more consistent performance in terms of the pump itself. The 12-volt booster pump in and of itself, I think, is for non-continuous duty, right? So you'll see that we put them on the fill and go for when someone needs to boost the production from time to time. But really, if you were to run that thing for 6 or 8 hours, it puts a lot of strain on that motor, and you may burn up a pump a lot faster than you would want to. So if you're in a situation where you can go with an electric booster pump and supply it the power either from a house, from a building, or from a small generator, then I would definitely go that route if you can.
Cool. Very cool. All right. Getting into our other questions. This is something we get from time to time. People wonder why we don't offer a gas-powered booster pump system with our cart with one built on.
Yeah. I think the number one reason why I haven't ventured into manufacturing them is, I guess I would say twofold. We're a volume manufacturer, right? So it's kind of a niche demand, a niche application. But the other one is more of a practical one, and it comes down to the noise. They're really loud compared to like a generator, or even, if you get like a Honda generator or some of these knockoffs that are pretty quiet, made to be a lot like a Honda in terms of performance and sound. Those generators, you can't really hear them even if you just go around the backside of the house or inside. These smaller engines that are on gas powered pumps, the ones that we've explored with, they sound more like the engine on a weed whacker than like a generator or even a lawnmower. So it just really comes down to a lot of the noise.
Yeah.
And as we look into what makes sense to manufacture, we don't really want to put out products that are limited by markets.
Right.
So there's a lot of states, maybe not a lot of states, but a lot of people in big states that are affected by essentially legislation that shuts down the ability to even run gas engines and stuff. So we kind of keep an eye on that in terms of what we want to look at from a production standpoint. But for me, the biggest one is probably the noise associated with it.
Yeah. A lot of times, it's when I was a service provider cleaning windows, we wanted to really make the customer feel at ease that when we're there cleaning, and the last thing you want to do is just cause a lot of noise, for sure.
Absolutely. A generator and an electric booster pump will give you the same performance, and it's a lot quieter. And then you have a generator for just about any other application you could run into as a sole operator. Use it for just about anything you would want, camping, whatever else it might come in handy for.
Absolutely. So another question that we get is, do pumps need to be supplied with water from a tap, or can they siphon from a tank?
Yeah, so all of these pumps are designed to be able to siphon. And there are caveats, right? So you might run into a situation where you say, well, I set up this DIY setup and I can't get it to prime. If you're going to set up a pump and run, X number of feet of line, it's going to have all that air that it's got to prime through. And so we're seeing more and more of kind of these custom builds and DIY setups where people will buy, kind of our components and build their own thing out of them. And what we've begun to point out to people is, it's probably a good idea to look into getting a primer bulb.
Mm-hmm.
They make these for the fuel industry, but they work just as well in the water world. If you put that on the long line you're running from the inlet of the pump towards the tank you're trying to siphon, if you can't get it to siphon, then you just basically a few pumps of that primer bulb and it'll draw that for you. The other way to really kind of figure that out, frankly, from a what do I do if I can't get this thing to prime in the field standpoint, is put some positive pressure on the output line, right? So find a way to create suction there, whether it's you pull a hose and you literally try and pull water through with your mouth or whatever the case may be. But a primer bulb is usually only necessary if you're running long runs in a custom situation. All these pumps are designed to draw water from tanks.
Very cool. Checking in over in Facebook, we have our good friend Manny in Puerto Rico checking in. Hope you're doing well.
What's up, Manny?
Other question here for you. And this is a very common one. So how much power do these pumps require, and what sort of battery or the generator is it required to power them?
Yeah, so on the electric one, I mean, it's a standard outlet. If you go to Mrs. Smith's house and there's a plug on the front porch or the back deck, you shouldn't have any risk with plugging that in and kind of blowing a breaker or anything. It doesn't pull, too many amps in that sense, so you shouldn't have any problem from there. When it comes to the pumps, the delivery pump being much smaller than the other is going to draw a whole lot less amps, right? But it says right on the pumps. So if you're ever wondering about this, get to the pump label, and just like it says the flow and the pressure and all these other variables, it says right on it the amp draw. So this pump here will draw 9.9 amps at max, right? So where's it at max? At max is actually right before it shuts off. So it's not usually drawing the max amps. So you can look at it on there, whereas on the larger 12-volt booster pump, it's actually 25 at 90 psi. So when this thing is creating 90 psi of pressure, it's drawing 25 amps. So you want to really pay attention to that from a design standpoint. If you're into the DIY world, throw a couple of those into a situation, and you're drawing a lot of amps, obviously. And that really kind of plays into, okay, well, what size battery do I need? First we'll start with what kind of battery. There's two types of 12-volt style batteries, right? You've got the kind of battery that's made for going into like a vehicle, where when you crank the engine, it's supplying a whole lot of amps all at once to turn the engine over. And then you have what's called a deep cycle battery, where it supplies a low amount of amps for many, many hours. So you always want to look for a deep cycle battery. And this is more like what you would put in your boat to run a trolling motor, or a golf cart would run off of, or different things. But if you go to a local store, and you even Walmart, and these guys have trolling motor batteries, deep cycle batteries, you want a deep cycle battery, not a standard battery.
Right.
And then you want the biggest one you can afford, frankly. I mean, that's what I tell people. Or you want two that you wire together and get the capacity of one doubled, right? And so all of these deep cycle batteries have right on them an amp hour rating, right? So the amp hour rating is, let's say, 60 amp hours or 100 amp hours. Well, if you're running a pump that's going to be drawing 20 amps and you've got a 100 amp hour battery, you're going to get somewhere around 5 or so hours of runtime out of it. So you really want to pay attention to what size battery you're using, but be sure to go with deep cycle over the other car style batteries, first of all. And if you find, okay, I bought an 80 or 100 amp hour battery and it's not enough, you might get another one and simply wire them together properly to double the capacity. So two 100 amp hour batteries wired together is going to give you a whole lot more capacity, obviously. So I know we have a few customers that do that for much larger setups that are 12 volt.
Yeah, absolutely. And there's other options too to look into. When I was with Super Clean, we had the battery isolators. So we're charging as we're driving. So I remember taking the van home. Never really had to worry about, did I charge it? Just ready to go.
Yeah.
And if I was in the situation where we needed to increase performance, the boost the production side for an extended period of time, I'll turn on the van just to make sure. Never had an issue there.
Yeah, the battery isolators are great. And if you're not familiar with that, what it is basically a device that you wire to the vehicle to alternator, and then off of the alternator to your battery. So anytime the engine's running, you're charging the battery off the vehicle alternator. You just want to be sure you don't do that kind of thing without the right device.
Right.
Because you'll drain the vehicle battery if you kill your deep cycle battery at a job. Right. And then you'll be stuck at Mrs. Smith's house.
Yeah. Not a good situation. Going back to Instagram, sent the glass restoration, just chiming in here. The electric pumps are great. We've had one running every day for about 6 hours since 2016. No issues. Great product.
Very cool.
Great feedback. Going back into our questions, common when we get, what is the minimum maximum pressure recommended for use with RODI?
Yeah, the minimum is kind of just like a practical thing, right? If you're delivering 20 psi or so to an RO system, you're probably not going to get much production out of it unless it's a dual RO system like the 4060, right? The max output's a dual RO, but it has a pump built in. The 4060 sort of eliminates some of that because it has such high capacity from its membranes. But what we tell people generally is you want 40 to 50 psi from the property going in. Now, when it comes to a maximum, everything we build is designed to work at less than 120 psi. So like the battery powered pump, right? It's a 90 psi pump. We regulate the electric booster pump systems to where they're not going to give you any more than say 110 to 120 psi. You can probably go up to about 150, 160, but you don't really get much more production out of the membrane if you're not able to supply it the volume of water. So pressure and flow are obviously two very different things. It doesn't matter how much pressure you put into it if you're not giving it enough volume. And one of the things you'll run into, especially with electric booster pumps, is if you're running one of these in an area where you have really low volume of water coming out of the property, what you'll find is you'll have air in here, right? So anytime you're trying to draw water through something and there's not enough volume of water, you create air in the lines. Well, that air will create cavitation inside this pump and destroy the insides as well. So you want to be sure you're always running, 3/4, 5/8 garden hose line into these. You never really want to use smaller, hoses. Certainly not pull tubing or even the yellow 3/8 delivery
Right.
lines, because they're designed to move more water. So it gets pinched down to this half-inch size when it enters the pump, and that's about as small as you want to go from that standpoint.
Very cool. Very cool. Awesome. So that was our episode 5. I apologize for going late for our technical difficulties. Just to recap, we went over water-fed pumps, whether it's a 12-volt booster, 110-volt booster, delivery pumps. If you're just now logging on and catching the end of this, we leave these videos up on our Facebook channels. So just to recap on where you can find this live stream or the upload of it. So you can head over to our Facebook business page. So it's RHG-Tucker Pole Systems on Facebook. Facebook group page is Tucker/RHG Window and Solar Cleaning Group. And our YouTube channel is Tucker USA. Just a reminder, we're celebrating our new website for all of April. So be sure to use the coupon code TuckerUSA at checkout to save 15%. So no space between, let me see. I think I didn't copy this right.
I think there's a 2024 in there.
Yeah.
It's all over the homepage. So if you go,
it's all over the homepage. Go to tuckerusa.com. Here it is. Nick, our moderator's chiming in. Tucker 2024. No space between Tucker and 2024.
Yeah, some big savings all month, that's for sure.
All right. We appreciate you guys hopping on with us. We'll look forward to our next week, episode 6 of Waterfed Wednesday.
All right.
Take care.
Take care, everybody.